But either way, glad to have you here, hoo hoo. How's it going, everyone? Just getting YouTube started up too. I don't know why, but I don't really like showing YouTube my starting Zoom screen. So I always start YouTube right as I switch over. Oh, did Spectre just get first in Dip? That'd be kind of funny. I kind of respect that if Spectre did that. See, if it was here, but he might have just gotten first and then had to leave again. Okay. I think we're all good to proceed. I don't think we have any questions like I've been waiting in my Discord. No, yeah. So let's look around online for now. Oh, Spectre's there, okay. I should have muted when I drank. I just touched my mic. What the, dude, why is my mic this high up? Okay. My lovely Spectre. My precious. Lovely manly dog. I'll take it. Yeah, please always call me that. Lovely manly Don. What's... Oh. Beer is free? I'm missing out. Where's my free beer? Okay, anyway. I don't care about that. Let's give her homework help. Oh god. It's gonna be one of those days where everything is answered. If it is, I'm just gonna go right over to abstract algebra stuff. Also, I was awake at a decent time this morning, but I got out of bed embarrassingly late, so I haven't eaten breakfast yet, so I got a little snack right here. Alright, so one has an answer. I mean, compared to you, Spectre, yeah. Your sleep schedule's on another level. Ooh. Got differential equations with a circuit. Find L if E is constant. I was awake at like 9:30, but I got out of bed at like 11. It was just like, my bed is so comfy, I don't know how to get out of it anymore. Yeah, everything about you is on a different level, Spectre. You just you're an elite person. Your bed is comfy too. Who? Yeah, exactly. It's like I'm so like warm and cozy. Why would I ever want to leave? So I have no idea how you set this up, but let's see what they did. Does that say foo? No, it's 500. Okay, that's a 5, not an F. And here, I is just, it's a variable. It's not the imaginary number. Okay. Freaking physics, man. Same emoji color and the background color. Oh, the chat that I'm looking at is like dark mode, so it's all like a... Whatchamacallit. Oh, they actually, yeah, the border of it is the same color. If that's what you mean. Find L if E is constant. I don't see any L's or E's. I do see I's. There's an E. There's an L. RLC circuits. I remember vaguely learning about RLC circuits. Resistor. What the heck is L again? C is capacitor. I guess it doesn't really matter though. DIDT. Yeah, exactly. Linux physics. I was having a hard time with that too. So, I mean, this is a second order differential equation. They don't, if they're doing this, that seems like something that you get from a separable. Hey, Dumoed. Yeah, please, let your question rip. I wish they kind of showed their setup. It seems like the result of something that's separable. I guess they have di by dt. Complete the square of negative x squared. If all you have is minus x squared, that square is already complete. Or do you mean just like any completing the square where you have a negative sign in front of the x squared? Let me go to the whiteboard. So it's not just negative x squared, it's like negative x squared plus something else. Oh, shoot, I didn't finish. I need to put my phone on the charger. There we go. All right, so if you have like a, let's call it y equals minus x squared. Let's give myself something that's factorable. I'm getting messed up because there's a minus sign in front. See, it's messing me up too. Minus x squared plus 5x minus 6. That's good. Okay. Oh, hard locked. I freaking love that screaming dog so much. Thank you so much, Hardlocked. I appreciate you. Am I looking at the sky? I don't think so, hoo hoo. Yeah, huskies are so cute, and I love how they just scream. I love any video of a screaming husky like that. It cracks me up. But so yeah, so Tumod, if you have a quadratic like that, which I think you said you was more or less like the situation that you have, okay, I would just factor the negative sign out and deal with it later. Personally, I think there's a different way you can work around it, but this is the way that makes sense to me. So I factored, you know, I'm saying I factored out a negative sign. I really factored out a -1 if I'm being technical, but I factored out a negative sign. It's just an easier way of saying it to me. And now we can just worry about what's inside the parentheses here and just do our normal completing the square procedure here. Actually, why did I bother giving myself something factorable? It's not going to be the best example. Actually, I should specifically make this not factorable. Sorry. Because completing the square, it's a bit more informative if I show you an example that's not factorable. Actually, for this one, it doesn't matter for the way that I set it up, but oh well. I already changed it. It doesn't matter. Oh, I shouldn't give myself an odd number, though. We changed the problem again. 8. There we go. So yeah, now we can do our normal completing the square procedure. So let's get the Working only inside the parentheses here, ignoring the minus sign out front. Let's do our minus b over 2a. Oh. I gave myself an... terrible. I just want to avoid fractions here, and so I want something that's like not going to give me a fraction here, or it's going to like simplify. Or 4. Okay. And I made that an even number because I wanted the 4 to cancel with the 2, just for the sake of an example. So the negative and negative becomes positive. 4 over 2 is 2. So let me just label what I did there. Minus b over 2a. X squared minus 4x. And so we are going to add that squared, so plus 4, and then subtract it off, minus 4, and then the plus 8 is still there. And then this piece right here will give us a perfect square. So by the way it's engineered, it is always going to be x minus that squared. Minus 4 plus 8 is plus 4. And now I'd want to do one more step, which is multiplying back out the negative sign, like distributing it. So it goes there, and it goes there. So I would call our final answer minus x minus 2 squared minus 4. You could keep it in that form too. It's all the same. But I like this a little more. Hope that makes sense. Oh, you want to see that example instead? I can do that too. Now it's going to look a little weirder, but we can do that. Okay. So we have this, we can't, it's not quite as simple as just factoring. I mean, you could still factor out a negative 3 and then just work the inside of the parentheses. That's still valid. But you're going to get a fraction here with 2 over 3 and things get a little weird. So I'm going to specifically not do this way with factoring out just whatever's in front, and we'll do it kind of a different way. So I'm going to go straight to the minus b over 2a step here. So 12 over 2 times minus 3. The minus and the minus become positive. 12 divided by 6 is 2. Interesting. All right. So now what we're going to get we still want to square that and plus and minus it. Minus 4 plus 4. Then the minus 2 comes down. And I'm specifically taking it so that, so like right here I did minus 4 and then plus 4, but up here I did plus 4 and then minus 4. I always put the one first. I mean, you don't, the order doesn't actually matter, but just for the sake of visualizing it, I know that we're going to have to factor that chunk as a perfect square or that chunk as a perfect square. And I want the sign of that to match the sign of that. It just makes the factoring work. So I recommend that you always like kind of match the sign there for when you do the plus and minus. Now we have to factor that as a perfect square. And it should be where you start. Yeah, no, that's where I'm taking it. Dumod. Like, we're given this one, we have to get to that form. I appreciate the warning though, but I think I'm doing things right. So it's going to factor as the square root of that and the square root of that. What about the signs, though? Do you have to take the negative sign out of that? I'm trying to reverse engineer those. Yeah, I think we have to factor out the negative sign from this first, actually. Otherwise, the factoring gets weird. 4 minus 2 is 2. Now the inside, it's a bit more clear to me how you factor this, because having the negative sign in front and the negative sign there makes things a little weird to me. So it should be root 3x minus 2 squared plus 2. And let me like multiply that back out in my head and verify that. Actually, I'm going to multiply that out physically because I can't track it. 3x squared. No, that's not right. So you get 4 root 3? How do you do this? Do you need to take the 3 out? It doesn't make sense. This formula should work without it. See, I'm getting tripped up on this now. Do you have to just take the 3 out? I don't like doing that. I mean, you have to do it eventually, I guess. All right, let me try factoring the 3 out first and seeing if that makes it better. This feels weird to me that you have to do this, though. I feel like you shouldn't have to. But it's not working out if I don't, so. So I factor the negative 3 out from this chunk. X squared minus 4x plus 4 over 3 plus 2. I really hope this one works out. Let's see. 2 over root 3 squared plus 2. How does that factor out? The root 3 is really messing things up. Because our middle term isn't going to work out again, I don't think. Yeah, like, okay. It's the fact that we get the fraction that's really messing me up here. Let me put my mug away and I'm going to just look up the answers and I'll reverse engineer it. It should be simple, Yanis. I'm just trying to complete the square on that second quadratic down there. And I'm getting tripped up because the usual steps that I take don't really work. When there's the negative 3 in the leading coefficient and you get a fraction that doesn't, or you get like a fraction for your C. Wolfram Alpha knows all though, and yeah, I'm a math major to Moed, even though it may not seem like it right now. Seriously, Wolfram Alpha doesn't... 210. It's a clean number like that? How do we get there with completing the square, though? Should I factor the 3 out beforehand? Oh, okay. I see what you posted, Yanis. Let's see. So you factor negative 3 out right off the bat. And then this, you did +4 -4. And this 10 over 3 is -4 plus 2 over 3. Fair. Huh. I feel like you shouldn't have to do it like this, but this seems like the least error-prone way for me, at least. Alright, so let me go back through in the... I guess explain what's happening here. So yeah, I'm sorry doing that I'm getting tripped up on something that I should be able to do easily, but sometimes the questions like this just get me. So I guess I would recommend that you just always factor out the leading coefficient first, even though it's kind of annoying. I feel like it shouldn't be necessary, but I can't figure out a way to do it without it, so. All right, so let's factor out the -3 off the start. Plus 2/3. All right, now looking only inside the parentheses, let's do our minus b over 2a. Which is -2. Squared minus 4x plus 4 minus 4 plus 2/3. Matching the sign of that and that. This is going to factor as x minus 2 squared. If you get a common denominator there, it's 12 over 3, negative 12 over 3 plus 2 over 3, which indeed is just minus 10 over 3. That's so much simpler. Now you multiply the -3 back inside, and you get -3 x minus 2 squared plus the 3's cancel 10. Okay. I'm sure there's a way to do it without factoring the leading coefficient, but this way it's just so much easier to me when I actually see it, so I hope that helps. Doomwood. No problem. Let me know if you have anything else. Be cool to figure out this one. I don't know if I'll be able to figure it out quickly though. Wow, this person seriously butchered spelling across. I mean, I'm feeling that's this equation here, but you have to use V equals IR? I think that's an equation in circuits. Voltage is, what even is I? Current? No. It's the rate of change of current, right? Times resistance. Because Q is current, I think. I forget what I actually means though. I is current? Oh, okay. And what's Q? I guess Q is just charge. Okay. Thank you to my Q's and coulombs. That's right. Hey, converter, special unit J, where J squared equals plus I. I think you're right, Dumaled. This is a little familiar, converter, but let's see if we can figure that out. Conveniently, ij equals k. How do we represent e to the xj in terms of combination of sine, cosine, cosh, and sinh? You have to use power series. I guess, do you split? Do you take e to the xj, like the power series of that, and I guess split the terms up into fours that match cosh, sinh, sine, and cosine? Well, I wonder if the J changes things, but like, fours is funny. Because e to the x is just sine and cosine, but the J must change something if we're going to involve cosh and sinh. Well, it's also alternating, I guess. Cosh plus J sinh. Oh my god, if you... Okay. If you do e to the ix, the power series do check out with the signs. I didn't... Or it's being e to the x equals cosine plus I sine. I never knew that. It makes perfect sense. I should have realized that, but... So yeah, okay, if you have e to the jx now... I knew that e to the x is cosine plus I sine. I didn't realize the power series checked out with that too. Because I just never bothered to think about it. It makes perfect sense that it does. But here, instead of e to the x, we have e to the jx, where j squared is positive I. And that's going to change things. I mean, we can try working it out. I have no idea how it's going to look. Is this some kind of like Euler's identity equivalent for tessarines? So I guess with tessarines, you have potentially 3 different identities if you do I, J, and K. depending on how they work out, I guess. Ah. Is that already for tesserines? Oh, it's plus I, yeah. J squared equals I. Was it K equals IJ? Let's see. IJ equals K. Okay. Right, the way that you represent it. Oh, I never done a Cayley table. I don't know what those are. J to the 0 is 1. J squared is I. J cubed is K. Okay, yeah, fair. Multiplication table, basically. Okay. J to the 4th, is that going to be back around to 1, or let's see what would you put? Oh, -1, of course. How's that? Oh, I times I. Okay, fair enough. And then I guess now you cycle. Well, you don't. Now it's all of this repeated, but with negative signs. And then you cycle back around. That's my assumption. And a Cayley table is a more convenient way of saying that same thing. Okay. Well, e to the jx is... It is 1, yeah. Then, wait. I need to... Just e to the x. Like that. So e to the jx is n equals 0 to infinity. Jx to the n over n factorial. All right, plug in 0, you get 1. Plug in 1, you get jx over 1. Plug in 2, you get a... j squared x squared over 2. J cubed x cubed over 3. J to the 4th, x to the 4th. So I guess we... Oh! Zach, thank you so much. Hey, Brownie Man. Bobos, hey! Yes. Zach Ski. I was able to watch your stream for very long before I had to get started for myself, but welcome back. Even though you weren't really gone for that long, it feels like a long time because we missed you. So it's good to have you back. We're just working on this little tesserines question from Corrupt Converter, expressing e to the jx as a combination of sine, cosine, sinh, and cosh. Just kind of a little for fun thing. And it seems like a j, if you write out the powers, it kind of goes around in cycles of 8, right? Where it's like a normal imaginary numbers, I them goes around in cycles of 4. So I'm writing out each term, just let's go to the 9th, I guess, just to make sure our pattern does come back around. Don't know if this is tesserines. Oh, really? I just assumed it was, but... Hey, Brian. J squared equals plus I. I mean, I assumed it was tesserines, but maybe there's a slight difference. But anyway, that's not a plus sign. Must I checked. So now let's break out all the powers of J into how else they can be expressed. I'll keep the over one. So j squared is I. You know, let's even keep the factorials. J cubed we said is k. J to the fourth is -1. J to the fifth is -j. And then I assume we're going to group them based on the I, j, k, or not. And it'll be an alternating series for each of them. J to the seventh is -k, x to the seventh over 7. J to the eighth is back around to +1. J to the ninth is going to be the same as j to the 1. Okay. So then, do we not split this up into 4 different series? Ooh. Yeah, that is a little bit weird, though. I don't actually know the power series for sinh and cosh, but I assume they're pretty similar to sine and cosine. Why did I forget the powers of x? That was also throwing me off. So I guess let's try and rearrange this. So we have a 1 plus the only, oh, we have a -1 there. It's the fourth over 4. Plus 1 times x to the eighth over 8. Okay, those are all our 1s, plus dot dot dot, plus. We have our j's. We went back to the j out, right? Minus x to the fifth over 5. Plus x to the ninth over 9. I don't know, like this is gonna be, like this isn't like sine or cosine only. Which I guess is where the sinh and cosh potentially come in. X squared over 2 factorial minus x to the 6 over 6 factorial. Then we can... No. X to the 10th. Then same for k. Just adding 4 each time, and we're alternating. Okay, that seems to be our pattern. Cosh should just cosine and sine without the minus sign. Oh, that makes sense. It's going to be somewhat more annoying when we need something like sine x minus sine x, or sine minus x minus sine x over 2 trick. Okay. In Brownie Man, this is, I think, just a fun problem from corrupt converter of expressing, or corrupt converters have been working on these, so this might not be exactly tesserines as they've defined it, but a tesserine is like a, it's like a complex number, but instead of just a plus bi, you have plus, cj plus dk, Donkey Kong. And you can define like j and k to be j squared equals I and ij equals k. And so just the problem was to express e to the jx in terms of sine, cosine, cosh, and sinh. So yeah, it does seem like what Suzuki said is we're gonna, like, we need to remove terms for each of these series. So this is I mean, so if all of these are alternating, why would we need sinh or cosh if sinh and cosh aren't alternating? I'm trying to think about it. Like, I think I'm nearly done. We just need to make the final, like, realization here. Like, could we say it's, I guess so. We should probably write out those series. Zero to infinity. And so sinh and cosh are the same thing, but without the -1 powers. Makes sense. I had the series for sine and cosine up. I don't have the series for sinh and cosh up, but I'm just gonna assume that based on the exponential definitions. I want to do cosh first since I did cosine first up there. Actually, let me, you said yeah? Okay. I do want to look at the exponential definitions exactly of cosh and sinh because I do forget them. Hyperbolic trig exponential. Okay, sinh is e to the x minus e. Well, it's cosh first. E to the x plus e to the minus x over 2. And now we just do that. Sine, I think same thing with the minus sign in the middle. Yeah. Because they have to derive to each other. Okay. So Stugi was saying to do some kind of trick, like we take sine of x minus sine of negative x over 2 to kind of get only half every other term here. That kind of, it seems like it conveniently matches with those exponential definitions there, but I'm still trying to work out how that actually removes terms. Maybe I just need to write it out. That doesn't literally work. Okay. Hey, Mster IE over on YouTube. Glad to hear that you're intrigued. Sin x plus, yeah, okay, that's what I thought. Like, the odd function stuff doesn't quite work out with it exactly. Oh, sine plus sinh or something like that, because we want to get rid of Wait, are these signs even right? Wait, which one do I suspect is sine? I should probably answer that question first. I guess we would suspect both of these to be sine, just different combinations of sine and sinh, because we can do like sine plus sinh, and the negative terms will go away entirely, and I guess we divide by 2? Because to bring the positive terms back to normal? That must be it. Okay. So the fact that they're not alternating is actually helpful there. Hey, syntax error. This is a kind of for fun problem from a corrupt converter who's been doing these kind of like upload a 4-dimensional complex number where instead of a plus bi you have cj plus dk, and you can say j squared is I and ij is k, and you get all these like different relationships between things. And the problem was to express e to the jx as a combination of cosine, sine, cosh, and sinh, kind of like Euler's identity. So let's write out what sine plus sinh is in terms of their expanded series and see just what that gets us. And I'm gonna like do it like term by term. So I'm gonna do n equals 1 for both of these, and then n equals 2 for both, and then all that good stuff. Sine, you start positive, and I should just be, well, no, doesn't sine start negative? If you plug n equals 1, sine, that doesn't feel right. Thanks for actually doing the work. I mean, you're the one who gave me the idea, so sine starts. Hey, Juan Teo, if I'm saying that right. It's of your acuplacer? I never heard of that. In human, hello, welcome in. It's, I don't know, I kind of just explained it. It's like Euler's identity, but for this kind of like 4-dimensional complex number that we're working with, n equals 0. The series that I oh, it's n minus 1, not 2n minus 1. That's, I copied the series down wrong. There we go. Now it works. So yeah, x to the 1 over 1 factorial, and then from here, we get the same exact thing. Oops. Oh, thank you for the follow syntax error, acuplacer. Oh, really? Tests to advance into chemistry DC, pre-calc or physics DC. Well, considering I never heard of it, I don't know what to tell you to study, unfortunately. What? Does anyone from chat have any tips for studying for it? Because I've never heard of it. Hey, Big Eula. Yeah, I think that's an equivalent thing. Corrupt converter, we should get the same thing. The thing that I just copied from, I just inserted the 2 in there for some reason. All right, so now if we plug in n equals 2 to there, we'll get minus x cubed over 3 factorial plus x cubed over 3 factorial. So now, okay, good. These are going to go away. That's going to be twice as big, but we can fix that. And I think we can even just see the pattern already. So, okay, if we wanted, well, it's like, what do we have over here? So, the thing, this is negative x to the fifth, that's plus x to the fifth. So we're gonna need to insert a new alternating term, I think, which is probably okay. Or just switch whatever. Or just slam a negative sign in front of the sign or something. Wait, this question so sigma? Because it involves power series. So if we're going to start with this j portion first, we need to modify do they both need to be negative? And we're in business? Because we can't No, that just gets all the terms negative. It doesn't make it alternate. Maybe this is actually helpful to get back into summation form. Can you really teach me mathematics? I really want to dive deep into this. How can I start? I'll say my background is I have a bachelor's in applied math, and I feel comfortable answering things that are like calculus, differential equations, pre-calc, stats, geometry, elementary algebra, stuff of that vein. So like basically like calculus and below I'm pretty like comfortable with. If you have a specific question, please feel free to ask it. If I can't answer, I might be able to tell you someone who might be able to. But yeah, I guess welcome in. Probably have to give hints. Plus from alpha for 4 things. Okay. Yeah, the issue of the signs here is kind of having a tough time with it. So that's what we have there. But we need to make this alternate. So we just slam. The first term is positive, so we're just... Well, we shouldn't do it like that, because that's no longer equal. Really, eraser? If this gets factored inside there, like how does that change? Or distributed? Negative 1 to the n minus 1 times negative 1 to the n minus 1. I think without thinking too hard, that just turns into positive 1. So this means we want sinh minus sine over 2. And syntax error, I have a Discord. The questions are kind of like first come, first serve, and I'll mentally like try and keep a queue unless things get super unmanageable. Oh, I see someone asked a differential equation question. People mispronouncing hyperbolic trig functions would give me the ick. They're impossible to pronounce. Shine? No, I don't think there's an agreed on thing. My professors taught me cinch. I don't think people really have agreed on a standard thing for those. I never heard shine. Coshine? Is this, so Emster, is that you who asked the question in the Discord? I think the functions really sparkle. Oh god. This is like caution cinch. Okay. Shoot. I think we have an actual homework question. So I kind of want to. Yeah, we have a couple of actual homework questions coming in. So corruption inverter. I don't know if we can kind of like skip to the end here. I think what I had there is at the end there is like kind of the answer for the J part, and getting the others is going to be a similar process. Then you multiply that by J, and you have that part of the series. And you'll get similar things for the other three. I think I needed it to make that conclusion right there. That's your D one. My math teacher made a mock exam for us to do. Has me stumped. All right, let's see if we can figure it out. But one second as I bring it up. And I see that Zumetto posted a question as well. We're gonna do there's differential equations first, and then we'll take a look at that. Actually, let's see how involved these are gonna be. If that series convergence question is quicker, we might actually do that one first, because this differential equation might be a little bit involved here. There's a bunch of parts to this question. And Frederick, you're not late. You physically cannot be late to the stream. You're not expected to be here. See, after correct converter, I'm sorry that I have to kind of like move on to a new question, but when people are asking like homework questions, I want to prioritize those. And I feel like I got the idea at least. So we have these two. Spurs fan, if you just put it there for context. Oh yeah, I appreciate that, because I wouldn't be able to figure it out without the context part there. Parts 2 through 4 are annoying. Fortune through the signs in the comments. Oh. 14, the signs are plus, minus, minus. Plus, minus, minus. Oh, okay, yeah. I think I would have gotten that even if you didn't say that. Oh. This first one, it's the divergence test. You never get to use the divergence test. Oh wait, no, it's not. Never mind, it's not. I got excited. Like the it's just like I like the divergence test because literally you take the limit as n goes to infinity. If it's not 0, you know it diverges, but ln of 1 is 0. So never mind. That's not conclusive. Shoot, I was hoping that these would be quicker. I don't know if they are actually going to be, though. How can we do this ln one? Hey, Mina, I am good. Hope you are too. Because the bottom, I think you just rationalize it, or you just conjugate it. The top one. Actually, is this just telescoping? 13 is telescoping? I can obviously see 14 being telescoping. I don't know how you get it to be 13. I think we'll work these series first. Just I think that they'll be a bit quicker than the differential equations. This ln one was funny. Can we compare it with just n squared over n squared plus 1? N squared over n squared plus 1 should be less than... And does that... Ooh. I don't know... I don't even... Oh God, that's such a weird one. I have a feeling that ln x squared over x squared plus 1 is less than just x squared over x squared plus 1, right? I don't really know why. Oh, well, that... Never mind. It's only in 1080p? Oh, no. I didn't change anything on my end. Twitch just doesn't guarantee transcoding. So I guess it's just unlucky that the stream that doesn't have less quality available too. So I'm sorry, there's not much that I can really do about it. I'm saying the same as just Twitch, depending on their server load, will either give you or not give you transcoding. All right, let's work the second one first, just so we can get that one off our plate. The ln one I'm still not sure about. Could it be? No, I don't think it's gonna be integral test, right? Integral test might require it's positive too. Okay. So if we start with 14, integral test should be used. Oh, it should not be used because it hasn't been shown yet. Okay. Sorry, Mina. We have sigma n equals 1 to infinity. Root n plus 1. Actually, should we just go straight to plugging in terms and show that it's telescoping? Because I feel like this is telescoping. Let's just investigate that. If we plug in 1, we get root 2 minus 0 over 1 plus root 3 minus root 1, 2. No, the n messes it up. Never mind, it's not telescoping. If there wasn't the denominator, it would be. All right, so usually with these, I think you want to conjugate whatever the radical they give you is, and it usually cleans up to something nicer. That's n plus 1 minus n minus 1. N root n plus 1 plus root n minus 1. All right, so in the numerator, what happens here? N minus n is 0. 1 minus negative 1 is 2. And then what do we do there? Do we compare with a p series? Because that's on the denominator, we have a power of 3 over 2. So, I mean, I suspect this would converge because the degree is 3 over 2 on the bottom. What do we claim is greater than this that converges, though? 1 over just root n? Or I guess we can say 2. Wait, root n does not converge. Between 1 and 3 over 2, right? So, number between 1 and 1.5. So what about 1 and 1/4, which is 5 over 4? Is this true? If it's being raised to less of a power, it is a smaller number, and 2 over a smaller number is a bigger number, right? That's how we can think about that? I don't know about that syntax error. Plug this into Desmos quick. Actually, wait, I feel like Paul has a section on series just like this. Hey, Maverick, thanks so much for the kind words. Sorry, I know the screen capture is weird right now. I'm just trying to quickly... Comparison test or limit comparison test? Oh wait, x to the power 4 is less? No, it's greater than. Okay, cool. I think my logic is good here. So the blue line is x to the 5 over 2 over x to the 5 over 4. So this is greater, and it converges by the p test. P series, well, whatever. So yeah, since 2 to the 5 or 2 over n to the 5 over 4 is greater than this, and this converges, then the original series converges. Because so yeah, I'd say that 14 converges. Now for 13, it's a tricky one. Do we divide these? Does that help us? Or if we say that... Oh, maybe we use like log identities. But let me try just like rewriting this. So let's say that n squared is the same thing as n squared plus 1 minus 1. So n squared plus 1 over n squared plus 1 is 1 minus... This might not even be right. Oh, wait. I think this is the wrong track. This might just be telescoping. We want to use log identities. I think I see what Zach was saying now, that it's telescoping. I think it is. Because with log identities, if you have division inside the log, you can subtract the two logs, right? And that seems pretty telescoping to me. Let's try... You tried, but you failed. No, it's wrong? Ah. What's wrong with it? You get ln of 1 minus ln of 2 plus ln of 2 minus ln of 3 plus the square? Messes it up? I need to actually see it to believe it. ln of 1 minus ln... Oh! Maybe, yeah. This is ln of 2 squared is ln of 4 minus ln of 5. Oh, okay. You're right, you're right. It's annoying. We can still say it's the same as ln of 1 minus 1 over n squared plus 1 by what I did earlier. I don't know if that helps. Subtraction inside a log we can't do much with. Hey, Cruz. Transforming it into a product? I don't know. I don't know what you mean with like making it into a product. Wow, what a hard one. I'm good. How about you, Cruz? Oh, that's not ideal, is it? Let's consult with, who should we consult with? Should we consult with Paul? You passed Calc 1A, that's awesome, Cruz. Oh, what is product, though? Oh, ln of product. Oh, that's like an identity? Thanks to me? Oh, well, thanks. I really appreciate that. Hey, Dan. I mean, I only have a couple questions, but I'll take it. Does anything special happen if we divide? Capital pi notation? I mean, I don't think we're supposed to do that syntax. Especially, I don't know how that would work either. Oh, because you have sums of logs? So you could rewrite it as a product? That's probably... I think it's probably a valid manipulation. I don't know if it helps. It's probably not what a calculus student is supposed to do. I doubt ratio test helps. What the heck do you do with this? Does Wolfram Alpha know how to do these? Alright, I'm sorry to Emster. I thought this problem would be a bit quicker. If you did have to leave. What? Wolfram? Why? Wolfram! Stop it! You... Why? Stop it! Wolfram, I wanna... Okay. Oh my god, why is it doing this? There. Hey, Lofty. Question... misread a bit that said in terms of K? Oh, okay. Let me know if something... You have the question a shot. I'm not sure exactly what you're saying, but if something changed with the question, let me know. Or if you still need, like, help with it. Wolfram Alpha, you were... I fucking hate Wolfram Alpha. Oh my god. Converges by the integral test? Does it? I don't think, oh my god, sorry, I'm raging at Wolfram right now. Whoever asked the question, Zoo, sorry. It's allowed to use the integral test. Big math test today, a little bit scared. Well, Puppers, good luck. I'll be able to do well on it. Algebra looks super messy. You think you screwed it up? Okay. I'll still take a look at it. How do you integrate it? This one has an ln. That one's way easier though, because u equals ln x. Well, how does it compare with the telescoping series? Type it into Wolfram. So, like, if you removed the squares and compared those two series, could you say that the ones without the squares are greater than it? I don't know if that's valid, or I don't know if LNs are actually going to follow that. Like, what if we compared these two things? It's less. Oh wait, we're in the negatives. So that's actually... Oh, this might be it. Because this definitely is telescoping and therefore convergent, right? And if this thing is less... Like, you know, it's closer to 0. I mean, like, when you say less, I mean absolutely less. I think that's what we do. We compare it with the telescoping series. I don't know how, like, I wouldn't be able to figure that out just by looking at it though. Like the relationship between these two things. And you know, Yanis, I tried typing into Wolfram Alpha, and Wolfram Alpha just decided to erase all my work because it's a jerk. Okay, maybe it's gonna behave now though. Telescoping diverges? No? Like, can you get the actual sum for a telescoping series? The first term minus the limit? Oh, you okay? I'm glad you put a cap on that because I was like, what does that even mean? Yeah, this baby converges. Interesting that Wolfram getting the actual sum. So yeah, Zumeto, I think that's the key. If I was taking a test in integration by parts, oh, okay. The larger telescoping series diverges? What? Telescoping series convergence. How would it not converge if you can find the actual sum? Oh, there is no last term, is there? The n approaches 1. No, it's 0, isn't it? Hey, Anders. If you take the limit as n goes to infinity of the original thing... Oh, wait, no. Well, we don't care what it actually... Okay, we don't actually care what it converges to. If we can agree that it... Okay, let's try and actually write this out. Because you do make a valid point about the limit as n goes to infinity. But can we like fall back to this original form that does converge as n goes to infinity? Or, you know, the equivalent without the squares? That is less than n equals 1 to infinity ln of just n minus ln of just n plus 1. Yeah, we rewrite that back as a fraction, and that's... Oh, it's just ln n plus 1, isn't it? Or... It feels like cheating. Can we say it converges because the telescope's there? And for the sake of actually taking the limit, we use that? I think that's... I feel like it's valid. So like, that just approaches the first term. Wait, it doesn't make sense. It's ln of 1 and ln of 1? No, ln of 1/2. The limit of that as n goes to infinity is ln of 1, which is 0. And we can check that in Wolfram. What is ln of 1/2? Does it match with Wolfram Alpha's? You're going to hop out for a bit? All right, thanks for bringing out corrupt converter. Because Wolfram Alpha numerically got an approximate sum. So what is ln of 1/2? Let's see if it matches. No, oh my god, it's fine. It's fine. Minus 69. Oh, that's not the same. Oh, because one is n squared. Zumeto, I think that's the answer. In terms of what you are allowed to use for series if you have to use comparison tests. Not if you rewrite it as ln n over n plus 1. Right? Why can't you write it as n over n plus 1? Okay, I'm wrong. Why, though? Well, because I'm thinking it should be convergent because you can show that it seems to match a telescoping series, and you can rewrite it into a more convenient form for taking the limit. Zumeto, you're not allowed to use the integral tests? I don't know how else you do this, I guess. It's not positive, though. Okay, do I not understand something about limits? The answer is yes. Let's see what I don't understand about this. This is infinity. That's 0. That's what I was like basing this on. This frickin' thing. Doesn't work right. Hopefully it's fixed now. Thanks for telling me. I thought we were allowed to talk about the terms of the sequence because this is telescoping. I don't get the argument, but if we accept it as true, it seems the only option I can think of is an integral test, which Zumeto doesn't have. All right. Evidently, I just don't get this one. I mean, are you telling me this blue function goes to infinity? I guess. Okay. Well, okay. The sum is what you're saying goes to infinity. I don't know how you do a sum. Yeah. I'm sorry. Zoom out. I don't get. Just type sum. Oh, okay. Okay. Turns into an exponential. That's kind of funny. Okay, so our... Why is it different? Oh! That's why. Thanks, Zach. Maybe it's very slightly diverging. The upper limit is bad? Just wonder if you... Upper limit. Like, we can't literally do... How else would we do the upper limit here, I guess? Like, I know these are partial sums, but... That's just one number, though. It's just saying that the x's should be the terms. No? I don't get why that is an x, I guess. It's just a number. If the upper limit is just one thing, it's just a number. Minus ln x, or are those equal? Okay, we keep adding zeros. It does seem to diverge just very slowly. Yeah, I want to look at the actual behavior. So, I mean, I still don't have an idea for how to do this. I guess it... So the conclusion here is that my comparison is bad. Emster, you didn't miss anything. I think I've kept Emster waiting for long enough, so I'm gonna look at Emster's differential equations stuff, because that's one I'm kind of at a loss with. So yeah, I'm sorry about that, Zumedo. Algebra still in algebra ing? Okay. It's fair enough. I'm gonna bring this first part problem up. I do need to, like, my nose is running though, and I need to go wipe it. So one second. Some pavements, rainwater combines with carbon dioxide in the air to form acid rain, which dissolves in the cracks of the limestone. Concentration C of carbon dioxide and rainwater on any day can be modeled by differential equation. Okay. So this is separable for sure. It cycles every day given T is in days. And C is a percentage of carbon dioxide to rainwater as a decimal. Find the value of B. If it cycles every day given T is in days, then B is 2 pi? Because you do 2 pi over 1? Is that what you said too for part 1, Emster? Just to make sure I'm not already off on the wrong track? Oh wait. Well, it cycles every day, right? Send out on mean? You use it in a sentence bio? I'm not sure. I guess the cycle every day part, I'm kind of getting tripped up on the wording. Because if, like, January 1st of one year is the same as January 1st of the next year, then I think I agree with 2 pi over 365. But I was thinking like, you know, noon on one day is the same as noon on the next day. Send out on, like you send someone out on a mission, I guess. Like if you send someone like away to go do something. That's what's coming to mind for me, bio. That probably makes more sense if January 1st of one year is the same as January 1st of the next year. Otherwise it'd be a very weird climate. Yeah, Emster, I think I agree with you. If I don't get it right, I'll tell you not even American knew. Okay, fair enough. It's kind of a weird, like, that's a phrase. Like, and it's kind of like, you wouldn't find it in the dictionary. People just kind of say it, so. The model excludes values which represent concentrations above 0.9. They do say excluding leap year, which I guess should be included at 2 pi over 365. These two bits are meant to be in terms of K. Oh, really? In these years, the concentration become greater than 0.9. Oh yeah, I mean, if you don't know what K is, you just have to. Yeah, they don't give you hints as to what K actually is, so. You're just gonna be stuck with the K somewhere in there. So we're gonna have to solve this differential equation. Which we can do. It's gonna be some weird, like, e to the sine or something, isn't it? Let me switch back to this so I can copy it on the problem. Okay. So our differential equation is dc by dt is equal to kc cosine. And we agreed that b is 2 pi over 365. So let's plug that in. T. Okay. Yet sine inside of an e to the x. Okay. That makes sense. So let's when we solve this differential equation, let's divide over the kc, I guess. I feel like the kind of thing that only have differential equations is whether you divide the constant over or not, like it's kind of arbitrary. I feel like I always make the wrong choice, but I'm just gonna divide it over. I feel like it should work out either way, but I feel like I always get something that looks different. So either way, that's gonna integrate to k times ln absolute value of c. Cosine integrates to positive sine. I'm gonna mentally do a u sub here. And say 365 over 2 pi sine 2 pi over 365t plus some constant. I don't want to say c. Well, we can't say c, so let's call it d. All right. I guess we're going to divide the k over. Oh, it's 1 over k. Multiply the k over. Then do e to the power of each side. You don't tend to, but I'll just follow whatever. Oh, okay. It should work out to be the same either way. Because if you kept the k there, I do have kd instead of d. You know, we'll keep the k. We'll match what you do. Because a constant times a constant shouldn't matter, but let's just keep things the same as what you do. D. Well, now this step is redundant, but who cares? Which I think it's gonna be confusing to look at, so let's just erase that. Okay. We can rewrite this in a slightly more convenient form. We can say that we have e to the power of that times e to the power of d, and e to the power of d is a constant to a constant. Let's call it another constant, and I'm just going to reuse my names for constants because who cares? Okay. So I think that's our solution. Now the question is actually, if the concentration is above 0.9, how many of the years the concentration become greater than 0.9? Yeah, I don't know. They want us to answer the question, when is 0.9 less than this? You're not allowed to use a calculator? Well, I guess you can if we don't know the value of the constants here, do we? Are we given an initial point? I need to reread the problem. So we got D and K to deal with. No, I don't see an initial point. Not given until part 4? Oh my god. Well, maybe we just solve the inequality and let the constants be. We don't need an actual hard number here, do we? So divide the d over and take the ln of each side, I guess. Does the inequality flip if you take the ln of each side? I don't know. Kind of depends on the numbers involved, doesn't it? I'm just gonna assume it doesn't flip because that is more convenient for me. This is gonna be terrible. Like, we're also gonna take the arc sine of each side. I don't know how that plays with inequalities either. And arc sine I think is okay. Ln is increasing so it doesn't flip? Okay, thank you. Yeah, this... just saying good luck with this question. I mean, your teacher's asking for a mess of numbers here, I guess. Like, I don't know what else to do. It's like the D we can't do anything about either. It's like, this doesn't answer the question how many days a year, I guess. It only answers whenever... Like, whenever T is greater than this thing, the concentration is over 0.9. Does that answer how many days a year? I don't know. That is valued to just one number, so I guess it does. Oh, it's slightly blocked, isn't it? So yeah, I don't know what answer you could possibly give except for that. It looks terrible though. I agree with that. What happened to K? I forgot about K. It should be with the 365. Right there, right? So I can't think of a better answer than that. I wish I could. On what days does the concentration become its maximum? This one's a little bit easier. We can set the derivative equal to 0. We're in Discord, do you submit questions in the math homework help forum? Right here. Just make a new post there. If you ask me a question for fun, I might not do it. You can put it in the math discussion though. Yeah, I don't know what else you can do with that, Emster, so I guess that's what you get. For part 3, what happens when we already have the derivative, so we set it equal to 0. Now this is weird because we have C involved here, right? So we get solutions either when C is equal to 0 or T is equal to whatever cosine is 0. So cosine is 0 at pi over 2 and 3 pi over 2. Remember 2 pi over 365t equals pi over 2, or 2 pi over 365t equals 3 pi over 2. I think we have to break it up like this, which means t could equal 365 over 4. Oh, plus 2 pi n. Since C isn't equal to 0, it's okay to... Oh, we're given that C isn't 0? Okay. Should we do the next set of questions? It's too intriguing to watch. Okay. So yeah, we can, I guess, discount that. Plus 2 pi n, which means t is equal to 3/4 times 365 plus 365n. Now we need to figure out whether these are, well, we know the behavior of cosine, right? Cosine well, we know the behavior, well, I guess we can't remember the behavior of sine. So we don't necessarily even have to get the second derivative here. We probably could. That'd be a little bit tricky to figure things out, though. Actually, it might not be that bad. But I would say just knowing the behavior of sine, sine for things that are like pi over 2 is a maximum, and sine of things that are like 3 pi over 2 is a minimum. So I'd say our maxima are right here. On what days? Well, that's actually not too bad. So let's do 4 divided by 365. So 91.25. It's a maximum on the 91.25th day of the year. Of each year. Well, I guess we would say 91st. Max occurs on the 91st day of the year. I'm really bad at physics, but damn, do I like it. Hey, this is a chemistry problem? No, it's a differential equations problem that uses chemistry kind of like premise. Oh, titration? Yeah, I'm not doing that. It's like Yanis is interested in it, though. That's April 1st? Is it? I don't think it is. It should be in March, right? It is April 1st. That's hilarious. I wonder if it was engineered to be like that. Yeah. All right, so this is part 4. Hmm. Well, we can't find the value of k. Wait, how does this work? We have k and d. Can we figure out d if we know... Are we supposed to be able to figure out a value for d here? Because we're not going to figure out a value for k with just that one point. Hmm. So yeah, Emster, I agree with like that, but the thing is we have a d here. Like, I don't know what to do with the d. That's what she said. Like, you need 2 initial conditions to do problems like these. Or is there some weird thing where you can derive it back and figure out one of these constants? Yeah, me too, Emster. Let me look at some similar like modeling problems. It's like with population problems, you can do some funny thing to, like, you end up with 2 constants as well, and you can do some kind of funny thing to figure them out. They use freedom units. You're Irish. This is actually like gallons. No, dude. Freedom units are better. Like miles are longer than kilometers, and that's why they're better because they're longer. I don't know what you're on about. Oh wait, no, they do have two conditions here. Like a gravitational acceleration be meters per second squared, not feet per second squared. Yeah. Can't use your feet to do gravitational acceleration. I think you're just not trying hard enough then. Yeah, this is confusing. I don't know how we're supposed to do this. Well, I believe it's 32 point whatever for pew pew guns and McDonald's every corner units. Okay. Yeah, come on. 32.17. It's really easy to remember that. See, even it's bigger. 38 is bigger than 9. Yeah, that means it's better. You know, I'm sorry, but this is the way that the world works. I'm so confused how you do this. Is it supposed to be like, you know, at 0.9? I mean, I have to do with problems 2 and 3 where you figure out where like the maximum is 0.9 to do a corners inquiry on this. But excluding values greater than 0.9 could mean a few things. No, I don't. I'm a little confused by the wording of even 2. Like, if the model excludes values with concentrations above 0.9, the model is sine, and it seems like that implies it still goes above 0.9, so I don't really know what they're on about. What does e to the sine x even look like? Just out of curiosity. Wrong one. Ooh. It's kind of fancy. The repeated blob. Could you be able to plug this into the initial, like... If you could somehow justify plugging it into here, that'd be nice. I don't think you can, though. You don't know what DC by DT is, I guess. Yeah, I don't know how to get a solution here that doesn't include a D in it. I'm sorry. This is such a weird question. Ever getting to the odds of the exact wording same as your hand quantum tunneling through the earth? Fingers crossed. See, I'm sorry. I don't know if I have anything for you on this one. Like, I guess I'm missing something with D that I should have been able to figure it out somewhere earlier, but I don't see how. Subtitles just like it. Oh yeah. Fair enough. Like give a case for your argument that this question is somehow worse than all the female Ghostbusters. Yeah, I think it's the best I got for you. So thanks always for trying. But hopefully this helped you out a little bit with 2 and 3. It's such a weird question though. I don't know. Like I feel like we need just a piece of information here. So, yeah. Oh well. Thank you too. Back when anything arises? Yeah, please do. I can't find the exact problem. Oh well. I'm gonna move on from that series 1 too, because it's annoying. Hi. I think I'm gonna take a bathroom break here. I'll be back in like 2 minutes. Let me just see what's been happening. Okay. Yeah, I'll be back in like 2 minutes. Thanks everyone who's been with me so far. Okay, I'm back. I think I'd rather kind of do my, and I really hate, yeah, I think we're going to do some abstract algebra settings, and I don't see any questions from chat now. So we left off on getting used to modular arithmetic, and I think it'd be good to go and do some of the exercises. I saw Pen Center do some of these. Bubble stream. So Pen Center just yesterday did the first stream. The VOD should be up if you want to see. And I believe Pen Center. Are you in his Discord? You're not far behind at all. Let me bring it up. Because literally only one stream has happened. You caught that one? Oh, okay, cool. Oh, there's this reading group channel, which you might not have access to. I forget where he made the announcement. You might need to DM him or at him and ask to be added to it. But yeah, actually, I technically could add you to it, but I don't want to mess with Pen Center stuff. But yeah, there's just like a reading group channel where all the action is happening. Awesome. So yeah, and if you caught that stream, then you've caught everything there is to catch. Sounds good. See, I want to go through these for myself because I didn't have time to do them before the stream. And I saw Pen Center. I was kind of like working, but I was kind of distracted, not paying as much attention as I should have. So I don't really remember anything about these. Where are we? All right. One, two, three, four, 7, 8. It's like the extended list of questions. I think Pen Center just did an abridged list, but I'm going to do the extended list. Yes, you're reading it right now before you saw that cover pop up. Oh, nice. What's page 38? So I got to the end of the complex numbers part. Oh, okay, so yeah, you're actually almost where I am. Like I've read the induction part. Strong induction, I've heard of it, but I've never done one before. And then once I saw equivalence relations, I was like, all right, this is completely new for me. Let's go and do some of the exercises first. Mathematical induction round 2, yeah. Yeah, I've never done it before. So I probably will also. Well, okay. One, I feel like I can kind of I think I'm okay with 1. Relatively prime to n. So like for this, it'd be 2, 3, 4, 5. Well, is 1? 1 can be relatively prime to things, can't it? It's not a prime number. No, 1 does go into 5. Okay, never mind. So 1 wouldn't be relatively prime to 5, I guess. It's like 2, 3, 4, 5. 3, 5, 7. Make sure I'm not messing up relatively prime. This means they have nothing in common, right? Their GCD is 1. Oops, sorry for the mouth noise. Right, their GCD is 1. Okay. So the GCD... Oh, yeah, that's a good point. Yeah, because you could always take, like, you know, A or B equals 0, and then the S or S or T equals 0, and then, yeah. Okay. All right, so yeah, I don't really feel the urge to actually like write this all out. Same with 2 for the most part, but let's like verbally say a few of these. Like GCD of 2, 10, greatest common divisor, that's going to be 2. Least common multiple is 10. GCD of 20, 8. I'll say 40, but that's LCM. Greatest common divisor is going to be 4. LCM, though, is 40. $21 and 50. I think these are relatively prime, right? Yeah, so their GCD is 1. Their least common multiple, I think, must be 21 times 50 for that reason. Which means 21 times 5 is 105, so put a 0 on that, 1050. Now what about factorizations? We don't know how P and Q compare to each other. Maybe it doesn't matter though. Their greatest common divisor is P squared Q? No. Just P, no, it's PQ squared. Because they each have 1 P, and they each have 2 Qs. So PQ squared. The least common multiple that's where it's everything except what they have in common. So is it P squared Q, I think? I remember seeing in Pentagon stream that the product of two numbers is equal to the least common multiple times their GCD, which I never heard of, but it seemed like a helpful fact here. Okay, yeah. So I said their GCD is P times Q squared. So you multiply these together and then divide out the GCD. So it is just P squared Q. Okay, P squared Q. We could even wolfram this with some example numbers just to make sure it checks out. GCD of prime number 5, let's say. 5 squared. You don't think that's correct? Really? That's what I get for doing things verbally. PQ cubed. 5 times 7. The LCM can be... Oh. What did I say? It was P squared Q? Oh. Yeah, what's happening there? You're right. That's less than. So the GCD is indeed... Wait. What? Oh, I want the factors of 245, I guess. Five times 7 squared. That's what I said. PQ squared? I should be writing things down now, but... yeah, I said it was PQ squared, so that checks out for GCD. So then what's the LCM? 8575. Five squared, 7 cubed. Really? Oh, was I misreading? Oh, I was doing the exponent math wrong, I think. Yeah, I was missing the power of Q. Because I wasn't doing the 2 plus 3. I think I was doing the P part right. Minimum powers of primes in GCD, maximum power. Okay, yeah, that's a better way of saying it than how I normally think of it. Like, I come up with the same result, but I really time putting it into words rather than like having in common versus what's different. But that's kind of a terrible way to describe it. So I like that a lot more. So yeah, Yanis, my example agrees with what you put, and I think that's, if I actually wrote things down, I hope that's what I would have gotten there. I'm just being lazy and not wanting to go up to my whiteboard right now, I guess. All right, so I feel comfortable enough with 2 then. With 3, I did this actually the last time on stream, so I'm going to leave that alone. Depend center suggests 4. Yes, okay. Show that S and T are not unique. Is there a way to do this systematically? Basically saying that 7 and 11 are relatively prime. want to find multiples of them where they're one more, one less than each other. It's an Euclidean algorithm. Oh, okay. I guess you could solve for S or T and just figure out what inputs give you an integer. It might not be that hard. Let me try writing out my idea. I mean, I'm still saying like a guess and check method with what I'm thinking, but it's informed guess and check. Okay. So I was thinking just subtract one of them over and let's isolate T, I guess. Oh, never mind. I forgot the one is going to be a fraction also. So I don't know if this actually really helps us that much. I mean, I guess for this to be an integer, you can say that you want some multiple of 7 that's also a multiple of 12 because, well, yeah, that'll give you 1 over 11. That'll give you 11 over 11. So like, does 7 times 12 mean that we're in business? 72. So you would do, or not S equals that. You said S equals 12 and you do 72. That'll give you 71 though, over 11. That makes no sense. No, I don't know if this really helps you. Okay, I don't think my idea is good. I don't know. I'm just gonna. What's a good extended Euclidean algorithm, I guess? I'm too lazy to do. Oops, that's the wrong browser. Too lazy to do guessing and checking. Oh, is this guessing and checking also? What? Isn't this already your answer? I'm confused. Oh no, it's not in terms of the right numbers. One, 102, and 38. I haven't already. I still need to do. It's kind of confusing. I still need to do Euclid's algorithm and then reverse it. I feel like my brain's kind of imploded. Mm. So the book actually explains this at some point. I feel like the book went over Euclid's algorithm. Let's see. I guess not. Hmm. I gotta be honest, I feel like I just suddenly got stupid. It has been 2 hours and 45 minutes of math, I guess. I think I might just call things for the day, to be honest, because I'm just not feeling like going more. Um, Give him every few hours, and then he came. Yeah, I'm kind of like, uh, feeling that a little bit. I mean, to be fair, I do have food literally right here, but it's hard to eat on stream. Um, someone's what they encounter this stuff exactly. Trixie, this is also hey Trixie, this is these are like the preliminaries for abstract algebra that I've been working on. But I mean, this is really, I guess, more of like a number theory thing if you're to do a class on that. It's that number theory apparently is related to abstract algebra in some way. Math art? I guess so. Yeah, I'm sorry. I think I'm gonna wrap the stream up here because I'm just feeling tired. Me. Oh yeah, I forgot I was slowly stuff a lot. Used some of the book for your abstract algebra class in college. Oh, interesting. Okay. What's I about to do? Oh yeah, so I'm gonna cut off the YouTube stream here. So if you're here on YouTube, I appreciate you.